A fast-growing, thriving, modern city of over 2 million people. A big city where the tall office shores of one of the world's finest natural homes. From the heart of Sydney, on the river that bears its name, lies Parramatta. Today, after 150 years, a city in its own right. Much of Australia's early history began right here. Much of Australia's modern industrial history is also being written on what was once farming land that surrounds Parramatta. Many factories, such as the Amalgamated Wireless Valve Company, are located in the district. As might be expected, these factories employ many local people. Olga Smith, for example. Olga is a tester in a factory producing electronic components. A plant where manufacturing techniques are as modern as the space age itself. In fact, it's a very special Australian factory, where the password's precision. The electronic valves that Olga tests are built up in a series of closely controlled operations. First, the individual components and sub-assemblies are made. In the glass parts section, molten glass is fused and shaped to the metal connecting pins, ensuring a perfect seal. Attached to the glass envelopes are small exhaust tubes through which the gases and air in the valve will be evacuated at a later stage. In the grid winding section, grids of many shapes and sizes are formed on specially designed lathes. Many of these complex machines are built in the factory's modern engineering shop. After winding, the grids are cut to length, trimmed, and made ready for minute inspection under powerful magnifying screens. The miniature grids being wound here use wire that is only 1/10 the diameter of a human hair. Little wonder that trimming and checking requires the use of microscopes. The wide range of valves manufactured calls for a great number of accurately shaped metal parts. These are formed on machines of this type. Here again, many of these machines are designed and built at this factory. Prior to assembly, the metal parts undergo a heat treatment process in special hydrogen ovens. Firing of the metal parts in hydrogen ensures the high degree of cleanliness required in valve production. Typical of the high inspection standards maintained throughout the factory is the quality control section of the cathode department. Once the individual components have passed inspection, the valves begin to take shape in the main assembly area. In the age of machines, and with automation so much to the fore, it's perhaps a pleasant thought that in an advanced field such as electronics, people with their keen eyes and nimble fingers are still so important. A routine production line test, then the glass envelopes are fitted and the valves begin to assume their familiar shape. But these are not the only types of valve designed and built here. They are certainly not the largest. Here, in another part of the factory, a wide range of transmitting and special purpose valves are manufactured. This is a valve that is used for the transmission of television programs. The grid being fitted here makes an interesting comparison in size to the miniature grids we saw earlier. Jack Mackenzie. He's married and lives near Parramatta. His occupation? Process worker. Jack, at the moment, is preparing to seal the glass envelope, an operation requiring great concentration and a delicate touch. As usual with the expert, it all looks so easy. The valve is then evacuated and reheated to drive out any minute quantities of air or gas that may be trapped in the metal and sealed. Cooling fins are fitted, and the completed valve is then subjected to a stringent acceptance test. Returning to the smaller valves, the sealing and evacuation is carried out on this Silex machine. The valves are loaded and passed through a series of gas jets where the base and envelope are fused together. Then, while passing through high-frequency heating coils, the valves are evacuated and the final seal made. The finished product, ready for the aging process. To ensure uniform operation in service, every valve is operated for long periods in this special aging rack, during which time its performance is stabilized. From aging racks to final inspection. Here, the valve characteristics are checked against very precise specifications, and then they are tested under actual service conditions. This is the section where Olga Smith works. But for a little while, she and her colleagues can relax. It's lunchtime. The works canteen. For the 900 people employed here, it's both restaurant and midday club. A place to eat, to meet friends, to share a joke. The lunch hour. Time for a friendly gossip. Or outside in the factory grounds, time to glance at the latest dress pattern, to stroll in the sun, to laze. There's even time to catch up on your golf. John Much. He's married and lives on a small farm near Parramatta. His favourite sport, you may guess. His occupation, production supervisor in the television picture tube department. John is checking the first operation, that of thoroughly cleaning the tube prior to applying the fluorescent phosphor screen. Loaded into this specially designed rig, the tubes are slowly moved along an endless belt. A chemical solution is fed into them, and by ensuring that each tube is absolutely level and free from vibration, the fluorescent material is precipitated accurately over the inside of the tube face. The carrying solution is gently poured off, and the tubes are dried. Drying completed, the exteriors of the tubes are washed to remove any trace of chemicals. And then a transparent lacquer is sprayed over the fluorescent coating to protect it during later processing. From the lacquering process, the tubes are carried by overhead conveyor to the next operation. The extensive use of this conveyor system throughout the television tube department has resulted in a very smooth production flow. Here, graphite is applied to the inside of the tube to form an electrode capable of carrying the very high voltages used in a modern television receiver. After drying, the tube is aluminized. By vaporizing a small aluminium pellet inside the evacuated tube, a micro-thin film of aluminium is deposited on the inside of the screen. This process ensures a brighter picture and gives increased tube life. At the same time as the tubes are passing through the various processes we've seen, their electron guns are being assembled in a special air-conditioned and dust-free room. ensure very accurate alignment, the individual components are set in special heat-resisting glass. The base connections are spot welded and the finished gun is ready. It is here on this rotating rig that the tubes and guns come together. Gently and accurately, the gun is automatically positioned. Then, in a series of heating operations, the base and the neck are fused together. The almost completed tubes are then placed in armoured carriers, connected to powerful pumps, and are then passed through ovens where the air and gases are evacuated and the tubes sealed. Several methods of providing protection of picture tubes against external damage are used these days. This particular one employs the use of a glass safety screen that is bonded to the picture tube. Having been cleaned and polished, the protective screen is fitted to the tube, leaving an airspace. After passing through a preheating oven, the airspace is filled with a transparent bonding resin, and following a further heat treatment process, the completed tube is ready for final test. Rows of 20th century magic lanterns that bring a world of wonder and beauty right into our living room. Talking of beauty, here's Carol Elliott. Carol lives in the heart of Parramatta, loves swimming and squash, and combines beauty with brain, for she holds the responsible position of Quality Control Inspector in the Transistor Department. The heart of the transistor is a tiny pellet of germanium. Highly refined wafers of this quite rare material are accurately measured, then, after being mounted in wax, are scribed into tiny squares. After separation, the squares are fed into a roller micrometer to be graded in size. This machine is capable of separating squares which differ in thickness by less than 1/10,000th part of an inch. Precision indeed, and vital for satisfactory performance. In the first stages of assembly, a germanium square and a supporting tab are loaded into a carbon block. A tiny locating washer is put in position, and finally, a minute dot of indium, a quite rare element, is added. When full, the carbon blocks, each holding 30 assemblies, are passed through accurately controlled ovens where the components fuse together. These tiny assemblies are then spot welded to a base, and 2 fine connecting wires are added. With the use of microscopes, and with a very delicate touch, these 2 wires are bent to touch the indium dot, ready for soldering. Because of the delicate nature of the assembly and the need for perfect joints, the soldering is done by immersing the transistors in this liquid bath, which is maintained at a precise temperature. After washing, a routine production test. The shells are filled with a heat transfer compound. Then, in hermetically sealed cabinets, they are pressed onto the bases to make the final seal. The transistor is complete. All that now remains is final inspection. Application of the most modern manufacturing techniques and inspection methods has made the company's valves, television tubes and transistors renowned and sought after throughout Australia and in the overseas market. The company is proud of its association with Parramatta and the people who live and work there. It is proud of its products and of its password, precision.